All right, now let's work a bunch of examples and see if we can determine how to graph functions without using our calculator. The first one says to graph the function y equals f of x equals 3 times the cosine of pi over 2x plus 1. And what I want to do on these first couple of problems is just walk you through the steps that I like to do in order to graph these. At the end, we can use a graphing device to double check that we're correct, but really the goal here is to use the tips that we've learned on the previous slides to predict what the graph is going to look like. Excuse me. So the very first thing that I would do, step number 1, would be to determine those things that we just got done talking about. In other words, what is the amplitude? The amplitude is this number that's on the front, so that is 3. What is the midline? The midline is the line, always y equals whatever this plus or minus is, so y equals 1. And the period is 2 pi over my b value. Well, 2 pi divided by pi over 2, this is my b value, is the same thing as 2 pi times 2 over pi. And that gives me 4, so the pi's cancel out. All right, so we know that. Step 2 is going to be to pay attention to what kind of curve do we have. In this case, we have a cosine curve. And so one thing that is going to help you is if you can, as quickly as possible, get into your head what a normal cosine curve looks like. And to make this easier for us, I have a graph of one. There is what a normal cosine curve looks like. Now, in this case, let's see here. Let's just pay attention to a couple things. At 0, I'm at my highest point, and I should see the highest point again. What is the period of the normal cosine curve? Period is 2 pi. What is 2 times pi? Because I don't have my axis in pi units. 2 times around 3.14 is 6.28. So if I go out to 6.28, which is around here maybe, I see it repeat. So this is the normal cosine curve. I'm going to call that my parent function. So every single one of these that has a cosine, in my mind, this is what I'm thinking about. All right, and at 0 on a normal cosine curve, it looks like I'm hitting my maximum, and I hit that maximum again at the end. Halfway between, it's not right at 3, but 3.14, I'm hitting my minimum. And then halfway between there, I'm hitting my midline, and I'm hitting my midline. Okay, so let's keep that in mind. So let me change pens. I'm going to sketch in y equals 1. And actually, let me clear this graph for, well, I'll go ahead and keep it on there. Y equals 1 is my midline, so I'm just going to sketch that in. And my amplitude is 3. So from that midline, I'm going to go up 1, 2, 3. So that puts me at 4. And then I'm going to go down 3. So that puts me at 1, 2, and 3. That puts me at negative 2. There we go. So I took care of the amplitude, I took care of the midline, and now we need to talk about the period. The period of this function is 4. Now in a normal cosine curve, at 0, I'm at my maximum value. My maximum value on this new function is at 4. There it is. I put the border in. Now I'm not going to see that repeat again until I get down to 4, and that's when I see it hit its maximum again. All right, so I'm just going to go ahead and put a little curve on there so I know what's happening. All right, now what else happens in a normal cosine curve? Well, halfway between a normal cosine curve's beginning and end of the period, I hit my lowest point. So halfway between 0 and 4 puts me at 2. And at 2, I'm going to be at my most minimum value. So right there, it's my most minimum value. And then halfway between 0 and 2, in this case 1, before I was on 0, which was my midline. Now my midline is up here at 1. And you start to see what this is going to look like. Let me just draw this in. Helps a little bit. Where's it going to go from there? Well, halfway between 2 and 4 is 3, and I'm going to hit my midline again. And this is what I would say is one period of that function. All right, so let's just recap. On the normal cosine curve, at 0, I hit my maximum, and I hit it again at the end of the period. For my new function in green, at 0, I also hit my maximum, and I also hit my maximum at the end of my period. My period changed to 4 from 2 pi. Halfway between 0 and 4 is 2, and that's where I hit my minimum. And then halfway between 0 and 2, which in this case was 1, put me on my midline. And halfway between 2 and 4, which put me at 3, put me also at my midline. So that's what that graph looks like. A good idea would be for you to come back to this slide without it all filled in and see if you can do it yourself. All right, here's another example. This time we're dealing with a sine curve. But we're going to go through the same steps that we did before. The only difference is that our parent function or our basic function is not going to be the cosine curve that we saw before, but it's going to be a sine curve. So let's see what we've got though. We first want to identify the amplitude. What is the amplitude for this one? It's the absolute value of that -3, which is 3. What's that negative going to do? This negative on the outside, that negative on the outside is going to reflect the graph over the which axis? Over the x-axis. All right, what else do we know? Well, the +1 changes my midline to y equals 1. And how about my period? My period is 2 pi over the absolute value of my b value. Well, my b value is inside with the x, and there's nothing in there. So my period is not changing from a normal sine curve. So what does a normal sine curve look like? We saw that on previous slides. Here's what it looks like. Let's make sure you agree with me. Starting at 0, I am at my midline, and then when I finish the period at 2 pi, that's when I see it repeat itself, right? So from 0 I go up, I come down, and then at 2 pi I begin that process again. So I'm at my midline, and then halfway between, in this case at pi, I'm at my midline again, and then halfway between 0 and pi, I'm at my max, and halfway between pi and 2 pi, I'm at my minimum. One thing I hope that you're noticing is that in both of these cases, I really am paying attention to 4 key areas. And those 4 key areas are that period divided by 4. And the reason why that's so nice is because that represents the quadrants of my unit circle. And we're familiar with that. All right, so let's now sketch in what I know about this function. I know that I have a midline at y equals 1. So in red, I will put that in. And then from that y equals 1, I'm going to go up 3. So I'm back at 4. And I'm going to go down 3. So 1, 2, and 3. Looks like I'm at -2. So you can see that we have a little stretch going on there, it looks like. And my period isn't changing at all. So let's see. What did we say about a normal sine curve? We said that a normal sine curve at 0 is at its midline. So that's what we're going to do. At 0, we are going to be at the midline, and that's at 1. Now, we also hit that again at the end of our period, and we have the same period of 2 pi, so I'm going to put a point on my midline. And then I also see it again halfway between. All right? Now, halfway between 0 and pi, normally I hit my highest point, but because of this reflection around the x-axis, between 0 and pi, instead of hitting my most maximum value, I'm going to hit my most minimum value. And instead of hitting my most minimum between pi and 2 pi, I'm going to hit my maximum. And so this curve looks something like this. Now, I mentioned this at the beginning, but make sure that you do this. Once you've come up with what you think is a good sketch, go ahead and put this into your graphing device to make sure that we're on the right track. All right, here's another one. So I'm going to identify what is the amplitude. Now this one looks a little bit different, doesn't it? I'm not used to seeing a plus in the front, but because addition is commutative, I can rewrite this like that. So the amplitude is the absolute value of 3, which is 3. The midline is y equals -1. The period is 2 pi over the absolute value of my b value. Remember, my b value is inside with the x, and so I get pi as my period. Now, this is a sine curve, so I hope that the graph that you see looks like a sine curve to you. What are some of the characteristics that we know about? For a sine curve, we know that this is my normal sine curve. I should have labeled that last one, but this is just a y equals the sine of x. That's what that picture is. So we see it starting at 0, being at its midline. It's again at its midline at the end of the period, 2 pi, and then halfway between. That's what we're going to have also. But the difference is that we have a midline at -1. So there's -1. And then from that -1, we're going to go up 1, 2, and 3. And we're going to go down 1, 2, and 3. So we've shifted down. There we go. So we have the amplitude, we have the midline, and now we have to take care of the period. So in a normal sine curve at 0, we're at the midline. So I'm going to do the same thing. And then at the end of the period, I am also at the midline. So where's the end of the period for this one? The end of the period for this one is not 2 pi, but it is pi. So it's going to be right there. And then halfway between, I'm also at my midline. Okay? Now, what happens in between 0 and that halfway point? Well, what happened for the normal sine curve? I'm at my highest point. Well, my highest point is up here at 2. And then between pi over 2 and pi, I'm at my lowest point, which is at -4. So this graph definitely got compressed, didn't it? Looks like it got stretched vertically and it got horizontally compressed, which makes sense. So again, this is one period of that function. If you wanted to do more periods of the function, you would just repeat this picture to the left and repeat this picture to the right. Example 4. The altitude of the International Space Station, t minutes after its perigee, or its closest point, in kilometers is given by a of t equals 415 minus sine of 2 pi times t plus 23.2 all over 92.8. The International Space Station reaches its perigee once in every orbit. How long does the International Space Station take to orbit the Earth? Give an exact answer. So the first thing we have to do is sift through all of those words to determine what is the question. The question on this one ultimately is, how long does the International Space Station take to orbit the Earth? To me, what that question says in my mind is that you're starting in one place and orbiting is going around the Earth back to where you began. And back to where you began is where we begin to see it repeat. We know that as the period of the function. So what we really want is just that. What is the period of a of t? Well, we know that the period of a function is 2 pi over the absolute value of b. So we have to figure out what is b. Well, b is the value outside of the t, but within the sine curve. So that is 2 pi over 92.8. Well, remember, division by a fraction is the same thing as multiplication by its reciprocal. So the 2 pi's cancel out, and I'm left with not much of a computation. Looks like the answer is 92.8, and because t was defined in minutes, I'm going to say that the answer is 92.8 minutes.